So let me put it in this way. It's not recent, but when I started, when I was a postdoc with Professor Omar Yaghi, so I mainly worked with ZIF 8 and other ZIFs. If you see that the Nobel Committee's presentation, so you will see there are 6 metal organic framework they have mentioned. And on number 4, there is this ZIF 8, on which also I worked. I made that ZIF 8. It was some other persons made before me. But what I did is I used high throughput technique to make it, let's put it in this really fast, and screen these materials very quickly and so on. Excuse me. So this I could do. Now, afterwards, once I finished that project and few follow-up projects and all, then though Professor Yaghi wanted me to stay in his group for a little longer, but then I got the job in NCL. Then I decided to come back to my country and started my own research. So initially, I was making some similar kind of materials, metal organic frameworks, and so on. But in about 2012, one of my very promising student, Sharat Kandambet, who is a professor at Shivnadar University at the moment. So Sharat, and I'll give complete the credit to him. So he came up with this idea that we can also make covalent organic frameworks, which is a variation of metal organic framework. Only thing is, it is exactly same like metal organic framework. Only thing is there are no metals. So without metal, there is a sort of, let's put it in this way, this is a metal organic framework, but there are no metals, something like that. So, however, when this was discovered once again by Professor Omar Yaghi's group, so these materials were not at all stable. So, any material must be stable so that it can find its applications in the real life. So these were not stable. So Sharat, and also these were very difficult to scale up. If you need, let's say, 100 gram of some material, it was not easy to make. And then if you need, let's say, some membranes, films, and so on. I mean, so those kind of things were not at all available at that time. However, so Sharat came up with this idea, and he said that we could do some trick that I'm not, that is called ketoenol tautomerism. That will be bit difficult for your audience to let's put it in this way, to grasp, because it is completely different, So if you ask me some questions on theoretical physics, I will not be able to answer anything, to be very bad. Anyway, now coming back. So he came up with this idea that we could do some tautomerization, and then we should be able to stabilize this material. So it worked, and we published the paper, and we also patented it. And subsequent to that, we also figured out a way to scale it up, and so on and so forth. And so that I consider, if you consider my contribution in this field, this is the one contribution, other than the work that I did when I was in Professor Yaghi's group, which was also mentioned in the Nobel Prize slide.